Hi, in the previous video we've learned what is integration, and we've deduced from the rules on derivatives some rules of integration. Now let's introduce some operation rules, and the first one is going to be integral of a sum. So basically this rule states that integral of two functions f of x plus g of x dx is equal to sum of integrals which then in turn can be found as f of x plus g of x plus c. Okay, so we're going to prove this rule, and we're going to use, in order to prove this rule, we're going to use things we already know. So, if I'm going to take a derivative of a sum of two functions, f of x plus g of x, what am I going to get? Well, because derivative of a sum is sum of derivatives, I'm going to get this. Right? I can differentiate each of these expressions separately without any issues. And of course, we know that this derivative is equal to f of x, and this one, g of x. Okay, so now let's name those three and just say this is going to be A, this is going to be B, and this is going to be C. Okay, first, let's start with the thing that A is equal to C. Okay, so I can write that dx f of x plus g of x is equal to f of x plus g of x. Look, if those two are equal to one another, then I can integrate both sides with respect to x. As a result, I'm going to get an expression like this. And look, we right away should know what is the integral, because if this is derivative of this, then integral must be equal to f of x plus g of x. But of course remember, because here we might have had some constant hidden and now we don't know about it, it's better to be safe and introduce this arbitrary constant over here. And this is integral fx plus g x dx. Okay, so look, what we got is actually that we get from the first expression on the left in our formula to the last expression on the right. So we definitely see that this rule must work. But let's go one step further. Now we're going to use the fact that B is equal to C. Okay, what do we get from this? Look, let's of course here we've got dx f of x plus dx g of x equals to f of x plus g of x. Now, look, what we want to get is what we have there in the middle, right? So maybe let's start by integrating all those expressions over here on the left hand side separately. Look, I should get that this is integral f of x dx, which is equal to f of x plus some, let's call it c1. Then, if I'm going to integrate g of x, I'm going to get g of x plus some c2. Right? Okay, and look, if I'm going to now add those two up, what am I going to do? This is f of x plus g of x plus c1 plus c2. Now the question is, how much is c1? To which the answer is, of course, I don't know. How much is c2? Again, we don't know. So if I have here c1 plus c2, why not replace them with another arbitrary constant, c. And look, what did we get from this? If I'm going to integrate each of these separately, doesn't matter how we look at it, we're again getting back to this expression, which tells us that integral of a sum is equal to the sum of integrals. Okay, so knowing this gives us one very important thing to remember. Look, if we have an integral to calculate, for example, integral out of x to the power of 3 minus 2, okay, not yet, minus x squared. Look, how do we do it? Look, we could, of course, write it as integral x to the power of 3 dx plus integral x squared dx. Out of this, we're getting that this is x to the power of 4 over 4. Sorry, that was, it should be a plus. We haven't introduced the rule for minus. Now, plus c plus x to the power of 3 over 3, c1 plus c2. But of course, we don't know how much is c1, we don't know how much is c2, so we can summarize them, sum them up, and subsume into one common c. But look, because this rule is so trivial, the best way to do it is right away to integrate each of these expressions separately and add c at the very, very end. Okay, so this is our first rule of operation. The second one is going to be called integral of a multiple. And this rule states that integral of k times f of x dx is equal to k integral f of x dx. Okay, so now that we, of course, first we need to mention that k is a constant. Look, what is this rule times? Let's start with the left-hand side. If I have integral k times f of x dx, this means that I have here expression integral of f of x plus f of x plus f of x plus f of x. let's use brackets, dx. And now my question is, how many f of x's I have over here? Well, here I am having k different terms. Now, knowing the rule that integral of a sum is equal to sum of two integrals, I can rewrite this as integral f of x dx plus integral of f of x dx plus until integral of f of x dx. How many terms do we have now? Well, we still have k terms. So in other words, we see that this must be equal to k times f of x dx, which actually finishes our proof. Okay, so look, what have we learned now is that basically if we have any constant inside the integral, we can take it out of the integral. And this is especially useful if we would like to actually provide a rule for subtraction of integrals. So integral of a difference. But look, over here, we see a very specific feature at integral of negative f of x dx is equal to the same thing as integral of negative 1 times f of x dx. So look, I can take this negative 1 out of the integral, and I'm going to get integral minus integral f of x dx. Okay, this is very useful. Why? Well, look, because if, for example, I have to integral of f of x minus g of x dx, how can I write this differently? Look, I can write it actually as the sum of two functions. This is going to be integral of f of x plus minus g of x dx. And look, now I can use the rule integral of a sum, which is equal to sum of two integrals. And now I can use the rule called integral of a multiple to take this minus out, and I'm getting that so what have we done now? Look, we actually proven that integral of a difference is equal to a difference of two integrals. Okay, look, knowing this, those two, even well, technically three new rules, because we have integral of a sum, integrals of a difference, and integral of a multiple. We've actually enabled ourselves to calculate way more complicated integrals than we did previously. So now let's just do a couple of examples. Okay, we're going to start with something rather easy, but we're going to move up to more troublesome cases. Okay, so let's start with this. Integral of x cubed plus x plus y dx. Okay, or let's just put it minus. So now, with the knowledge we've got, we know that we don't need to integrate each of these using some specific rule. We can just integrate each of these expressions inside the same way as we treated one component inside the integral. So I get out of this is x to the power of 4 over 4. Out of this, plus x to the power of 2 over 2 and minus x, right? Because 1 turns into x. And look, I don't need to write plus c1 plus c2 plus c3. Only thing I need is to put c at the very end. Okay, and how about this? Oh, let's do it this. Okay. E to the power 2x plus 14x over 7x squared plus 5 dx. Okay, here we will have to use a couple of rules we haven't used before. And look, what are these rules? First, over here, I'm gonna divide this into two separate integrals. So we're gonna have integrals of e to the power 2x dx plus integral of 14x to the divided by 7x squared plus 5 dx. Okay, and look, what rule do I need to use for this? Well, I need to use exponential. How did the exponential rule go? Well, it said that integral of f prime of x times e to the power f of x dx is equal to e to the power f of x plus c. Okay, so here definitely I need to use this rule, but there's the problem. Look, over here we see that derivative of 2x is 2. And what do I have in front of e? I just get 1. So at this moment I cannot use the rule, right? Because derivative of 2x is 2, I would like to have 2 over here. What can I do to have 2 over here? Well, look, this is very easy because of the rule that says that I can take any constant out of the integral. I can, for example, take out 1 over 2. And look, what will I have inside? 2. Because of course 1 over 2 times 2 gives me 1. 2 times e to the power 2x dx. But look, what I can do now is to use this rule. Because I have derivative up front. So now I know that this is going to be 1 over 2 e to the power 2x plus some c1, okay, but later when you know how to do it fast, you don't need to write the c1, but now let's keep it there. Okay, now let's see what happened, what is specific about this expression. Look, if this expression over here I would call fx, then what should I call this expression? Look, if I differentiate this, I'm going to get this. So this is f prime of x. Again, what rule should I use? Probably I should use logarithmic rule. And logarithmic rule says that integral of f prime of x over f of x dx is equal to ln absolute value of f of x plus c. Okay, and look, this is exactly what I can do over here. Look, I clearly see that this can be transformed into ln absolute value 7x squared plus 5 plus some c2. But look, in this particular case, we see that there is no possible way in which x squared times 7 plus 5 could be negative. So I can just write it as that. And the final answer over here is simply 1 over 2e to x plus natural logarithm of 7x squared plus 5 plus c. Okay, let's try just one more thing. So now let's just say that we want to integrate 3 to the power of x plus 1 over x plus 7 minus e to the power of x dx. Okay, look, again, not a very complicated thing to do once we know how to use the rules we've discussed. So out of this, we're going to get 3x over ln 3, right? Over here, we see division, but we also notice the derivative of this is equal to 1. So what we will have over here is natural logarithm, absolute value x plus 7, and that's it. And finally, minus e to the power of x will just give us negative e to the power of x, and we finish with plus c. Okay, so look, this gives us most basic rules about the integration. But this is not it, not everything. Look, there are 2 more extremely useful rules, and those are the rules involving substitution. And we're going to do them in the next 2 videos. First one is going to be called integration by substitution, and later, once we know how to use this one, we can use this knowledge to use a little bit more complex rule called integration by parts. Okay, thank you for your attention and see you in the next video.